Welcome to the Hyperscaling 5G Service webinar, where we'll be discussing what it takes to scale 5G and telecom services to the next level. I'm Catherine Speglia-Nin, the managing editor at RCR Wireless News. I'll be today's moderator. Before I introduce you to our three wonderful panelists, I'd like to get some brief housekeeping things out of the way. This webinar is being recorded and will be made available on demand at a later date. Please also submit questions for our panelists via the Q&A window throughout the conversation. And if we have time, we will get to as many of those as possible. Okay, and now for our panelists. It's my pleasure to welcome Vikram Sinappa, the Director of Packet Core 4G 5G Control Panel at AT&T, Osvaldo Aldao, the VP of Product Management at Enea, and Paul Britton, Principal PM Manager of Azure for Operators at Microsoft. Thank you for being here, gentlemen.
Thank you, Catherine.
My pleasure.
So Vikram, I want to start with you. And if you could first introduce yourself briefly, if you would like to, but then please tell us what benefits AT&T is seeing from a multi-vendor network and what the carrier's strategy is around its 5G standalone multi-vendor network.
Sure. So yeah, my name is Vikram Pujari Sinappa. I've been with AT&T for the last 17 years. I work for at AT&T Labs. I'm director for 5G control plane. So back to your question, Catherine. That's a great question. There are advantages and disadvantages to work in like a multi-vendor network ecosystem. Some of the advantages that, when we started building our 5G network is we went with the best of breed vendors for all the network functions. So we have a multi-vendor environment in our 5G core, as we did in the LTE core. So what this does is it helps us drive innovation. It reduces the cost. It helps us bring new services, to our customers. Be more agile and reduce cost, and also have like a positive TCO. This also allows us, to not have like a vendor lock-in because we have like a diverse vendor ecosystem. And some of the disadvantages with having multi-vendors is, it's the interoperability complexity. So we have like multiple partners, but the way we work around that is to work with our partners, communicate our requirements ahead of time, ensure that we have like a robust IoT framework in place. We have automation built in. We have good agile governance systems in place, and ensure like we have good testing frameworks in place. So that's our take on a multi-vendor environment, an AT&T network. Yeah.
Great, thank you. And Osvaldo, again, provide an introduction if you'd like. And then what is needed to secure a multi-vendor core network? I know that Vikram said there's pros and cons here, and I know security is a big kind of question mark. So what can you tell us about that?
Excellent. First, I'm delighted to be present here with my panel colleagues here. So looking forward for an insightful discussion. I'm Osvaldo Aldao, and I'm heading the project team in Enea. To your point, and building on what Vikram just commented, I think we all trust that, I guess that we all understand the benefits of having a multi-vendor strategy in terms of acceleration of these innovation cycles and as Vikram said, unlocking new service and flexibility to introduce new functionality. And to some extent, many mobile core networks today are multi-vendor, but typically that multi-vendor happens in different domains, meaning that packet core networks may be provided by one vendor, while the subscriber data management nodes are from another vendor. But it's not so common to see multi-vendor deployments within one domain, like for instance, subscriber data management. And the main reason for that is because historically, data models are owned by the telecom vendors and not the service providers. So maybe for those in the audience who may be unfamiliar with the concept of data model, it's good to clarify what it is. The data models are how permanent and dynamic information that may be from the user of the network is organized, stored, and accessed from other nodes. It specifies how to access information and how that information is shared across multiple nodes. And as I mentioned before, in some specific cases, those data models are vendor proprietary. And that's the reason why you very seldom see that, that an HLR or an HSS from vendors share the same data repository. So to recap, I think the data silos in the network, the complexity to share data across those silos, and the risk also of data inconsistency has been the biggest obstacle to service providers embracing this multi-vendor core network in this domain. However, in 5G, there is a big change, and that is because 5G and 3GPP has proposed a disaggregation of the network functions with open interfaces and a common data model. And that common data model is crucial, as in 5G, there is not only data from the subscriber, like traditional provision data, like IMSI numbers, or dynamic data, like the geolocation of the subscriber, but also there is a wide, broader range of what we call structured data, and that is coming, or sometimes called session data. And that is coming from many nodes in the network when you go into a cloud-native architecture. And that it represents 10 times more data and nodes than in the previous generations. So having in mind that the ownership of the data model by the telecom service provider is front and center in Enea's approach. And this allows service provider to secure the right foundation for these network functions from different vendors. And from our experience working, as Vikram mentioned, with some of the leading service providers, the success for a project, a multi-vendor project, I think from our experience goes around three main areas. First is to lay out a very clear set of interoperability standards and the network principles that all vendors must adhere to. Second is to establish a robust testing and validation process, as Vikram mentioned, to ensure that we have a seamless integration from those various components. And then the third one is to foster a collaboration ecosystem among the vendors, because that can facilitate that, how to turn around and to have a quick response time to solve problems.
Excellent. And Paul, I want to finally bring you in on this conversation. So welcome, and please tell us a little bit about yourself. And then, what are some of the biggest challenges that Microsoft has identified around multi-vendor networks?
Sure. Thank you, Catherine. And thank you to Vikram, Oswaldo, and everyone for being part of this webinar. I came to Microsoft 3 years ago, in fact, as part of the Metaswitch acquisition, which formed part of the Azure for Operators team within Microsoft. That's the telco-focused arm of Microsoft, dealing with both the infrastructure and some of the core components that are required in the telco space. Personally, I've been in that space for a long time, basically my whole career for quite a number of years, hence the colour of the beard. Worked with operators worldwide, and been a big part of what's been going on in this push towards cloud native and easier combinations of multi-vendor networks of the sort that we see at AT&T. Now, as Vikram said, there are lots of really good reasons to pursue a multi-vendor strategy for the core. It gives you best-in-class performance. That's both performance in terms of the occupancy actually on the cloud resources, but also, as Oswaldo mentioned, potentially fastest feature velocity by incorporating different vendors with different specialities. So there's a lot of attraction there for going for the multi-vendor approach. There is a flip side, of course. The flip side, which Vikram hinted at a little bit, is that you risk a fragmentation of the management tooling and the way that your different network function vendors are either stretching or constraining the options you can choose for the cloud, or the way that you actually manage deployments and configuration of that. So one of the areas that we specialize in Azure for Operators, and indeed my own responsibility, is what we call the AI Ops initiative, which is focusing on easing that composition of potentially multi-vendor solutions. Potentially, you may even In some cases, I've seen operators with multi-vendor, but also per network function dual vendor. So you can get very complex combinations of different choices for network functions and what vendor is supplying each. And then trying to manage those through lots of different tools is a potentially very large burden on the ops team. So we've tried to simplify that by concentrating on common tooling that makes it easier to manage that sort of hybrid estate made up of multi-vendors, both in terms of the underlying cloud, so providing a managed solution for the cloud, which is applicable to all the different vendors, but also the actual operational tooling in terms of orchestration and analytics and insights capabilities, combining those from all the vendors. And we see that as being a key part of making the success of a multi-vendor solution, is minimizing those downsides in order to maximize on the TCO benefits and velocity that Vikram is seeking in the strategy that he delivers. Yeah.
Great, thank you all so much. So Vikram, back to you. The subtitle of this webinar, it references scale, performance, security, and agility. That's a lot of things, but I wanted to ask which of these is dominant or front of mind for AT&T in its current decision making?
Yeah, it's all of the above. It's all of them.
Not surprised.
So at the scale at which we operate, and we need to be a very resilient network, very distributed. At the same time, we need to protect our network and our customers, from security threats. And we also need to be very agile, and automation is a key part. So we are focusing on all of them. They are all equally important for us.
Okay, and the kind of next section for our discussion is going to be the network data layer. And Osvaldo, I thought you could start by kind of telling us what the network data layer is and what problems you would say that it solves.
Yes, by all means. Thanks, Kat. So in traditional mobile core networks, data is distributed across network functions and is managed within silos. So that leads to many inefficiencies. For example, there is a high network complexity having to provision multiple of those data silos. You have data duplication with the risk of having data inconsistencies. You have different data availability, as these different repositories have different technologies. That also connect to scalability, as not probably all repositories can scale without compromising performance in the same way. And probably the most worst potential thing which we have seen is that it might be insufficient security capabilities also from one of those multiple repositories to prevent unauthorized access or data breach and potential disruptions. So the concept of network data layer was introduced in modern networking and telecommunications environment to address those problems. And it is basically a multi-tier cloud-native network function architecture with a clear separation between the application logic and the data storage. And that includes a number of benefits, like independent scaling of the storage processing, make much easier for service providers to be able to cope with different traffic conditions. Data is only stored once, and by that you avoid the risk of having multiple copies of the same data that can create data inconsistency. There is an implementation here of something in that network data layer, which is we call flexible data models. That means that every application that is accessing data have a different view, even if the information is stored once, and that can dynamically be adapted because those applications, the needs will evolve, and also the number of applications will also grow. So, and one of the very probably important things now is that the open APIs on that layer, because that layer is also exposing in an application programmable interface information to multiple other networks and elements, and that's something that is used by an effective implementation of a network data layer. So, in summary, a cloud-native network data layer has implemented a number of business benefits in terms of end-to-end operational efficiency, business development agility and scalability and speed, and also the scalability needed in managed in a kind of cost-effective way.
Great, and we will talk a little bit more about open APIs. And I know you mentioned cloud native, and actually, Paul, can you talk to us more about how becoming cloud native and implementing more automation across the entire network contributes or fits into this network data layer conversation?
Yeah, sure. Thank you, Catherine. So the network data layer that Osvaldo laid out, and indeed to some extent the whole service-based architecture for 5G is actually built around the concept of effectively decomposition to microservices. And in fact, that can happen at multiple layers. So service-based architecture breaks out the 5G core into multiple pieces. Each of those could be using the network data layer as its store, but each of the different network functions could themselves become decomposed into multiple different microservices. Many of them derived from pieces of open source, but a lot of individual domain-specific function as well. Some of those, maybe most of them, but not necessarily all, will also be implemented as containerized functions, so running on Kubernetes clusters. The problem with all that decomposition is it means it's very easy to swap things in and out and to optimize the scale of each piece, but you've now got a lot of pieces to get in the right place, and you have to get them all in the right place at the right time, at the right scale. So that's why automation becomes critical here. What's needed in order to keep on top of all of that is the telco needs to adopt a sort of DevOps approach. So very much the cloud native style of management as opposed to more traditional methods. Now DevOps means many different things. Most people just equate it to CI/CD, DevOps, they all mean the same thing. Actually, what I see in the telco world compared with some other industries is that the telco world is quite rightly, I think, very much focused on what I like to say is the ops end of DevOps. So it's all about the process of doing things at scale at the back end of what's potentially still quite a structured delivery process. And that's different from, say, some aspects of how cloud functions themselves are delivered, which is very much more integrated end-to-end to the, from the SWE team, the engineering team. That's for good reason. Telcos work in a regulated environment, so they need to understand what they are deploying and very tightly control the configuration because they have very strict reliability and performance requirements they must meet. So that all places requirements onto the automation tooling. And that's where, again, adopting cloud native approaches and built on what's been used to manage the hyperscaler clouds themselves is exactly what's needed here. In fact, one of the reasons why in Azure we're very interested in the telco space is across all the industries we work with, people like Vikram at AT&T have one of the few sort of industry vertical applications, if I can put it that way, referring to the whole network, that is of the same sort of order of size and complexity as the cloud itself. Whereas many other industrial segments, each individual customer is generally quite a lot smaller in complexity. So what we've aimed to do in Azure as part of this AI Ops initiative is to bring in a lot of the same toolings and experience of how we manage the cloud itself and bring those in. And we think that's what's needed, is to bring in that sort of capabilities to manage not just the individual deployments, but also coordination of what we call safe deployment practices. Other people might refer to it as canary tiering, but where you have to very careful, controlled, but still automated rollout across multiple tiers of the network, each of which needs to be gated, measured its performance before you go on to the next tier with potentially automated rollback. So that sort of capability is what's required in terms of the automation. Now, going back to what I said earlier, though, it doesn't all have to be Kubernetes based. There are still a lot of virtualized VM based network functions out there. They can all be incorporated into the same framework. So there's no need to equate cloud native with only Kubernetes. It'll be mostly Kubernetes, but it will be definitely based around that sort of DevOps mindset, and probably almost entirely with that sort of service-based architecture type of RESTful interfaces between each of the microservices. A lot of fun for the whole industry, bringing all that together and making it work reliably. But it's a good challenge. We enjoy it.
Yeah, and it's really interesting what you said about AT&T and kind of the scale of what they're doing. And we're really happy to have Vikram here, who can actually tell us a little bit about how all of this is playing out in AT&T's 5G network. So what can you say about that, Vikram?
Sure, Catherine. So for us, it's very important to handle the structured data, like, the user's identity, the provision data, and the unstructured data, right? Like in-session context of the user, authentication data. And all this needs to be stateless for us, for us to scale at which we operate. This has to be stateless so that the NFs, 5G NFs can access this data, get this data in a stateless manner. And also this needs to be highly distributed and scalable, right? So to Oswaldo's point, this context needs to be replicated across. It needs to be, because the user, it's not stationary, right? The user is moving across from one location to another location. So we need to make sure that, we can access this data seamlessly. We can scale it, with, especially as we grow our customer base, with IoT, where we have millions of users and policies associated with that. So having this data layer, with the structured data and unstructured data, making it stateless, highly scalable, reliable, that's very important, from an operator perspective. Yeah.
Certainly. And I said earlier that we're going to talk a little bit about open APIs as well. So Vikram, I'm going to go right back to you with this question, but, Osvaldo and Paul, please kind of jump into if you have something you'd like to add. So Vikram, what has an open AI architecture and the unification of data enabled for AT&T, whether that's use cases, application development, anything like that you can share with us?
Sure. So Open API, it's very important for us. It's like creation of network connections between our customers and AT&T Wireless and a wireline network, and connecting to the applications in the cloud right now on demand. So via Open APIs, this is possible. It's also enables us to expose a network using Open APIs. Especially with 5G, we have this network event exposure function where we can expose the network capabilities outbound. So we have a lot of use cases, especially with the connected car use cases, where we can do like fleet management via using Open APIs. We can say, hey, what time of the day is the best time to push like software updates to these connected cars? It allows us to define new services, by class. So we can say, okay, we need some low bandwidth applications, or do we need some ultra reliable applications to be running, or do we need, based on latency, right? So Open APIs is a key, for AT&T. And especially when you combine Open APIs with AI, it gives another dimension in terms of, leveraging new capabilities, exploring new, services to our customers, and also, getting insights into our network. And with predictive analysis with AI, we can, predict, hey, there is going to be some event in the next couple of hours. Or we need a surge of traffic is going to happen. So I think Open APIs is key to scaling a network, operating a network, and to what Paul said, right? AI ops team with Open APIs and the tooling, it's really important for AT&T.
May I add to that, please, Catherine?
Absolutely.
Yeah. So Vikram touched on the sort of Open APIs to the top of the network exposure function, and also hinted at some of the stuff at the back end, as well as the sort of input and configuration, which is the Open API and data model that Osvaldo talked about for the structured data layer. Actually, one of the areas that we think is particularly important is going to be Open APIs in terms of how analytics and metrics are pulled together, and also creating an open but still common data model for at least important aspects and correlators within that. And that's another area we put a lot of investment into, is trying to help create a platform that can process the vast quantities of data that comes out of telco networks in real time. And I genuinely mean real time, not vaguely approximating real time. So being able to do that is a problem of the sort of scale that the cloud is very good at. I mean, we had to solve the same problems to manage the cloud itself. So we put a lot of effort into combining that very streamlined processing path for that sort of analytics, working with multiple partners, the network equipment providers, as well as different teams within AT&T and other operators and Azure, to pull together all those pieces together so you can get insights across all the many different layers in real time, sometimes 10, 20 times faster than was possible before. That's both in terms of how fast you can process the data, but with that common data layer and that open set of APIs, you can correlate across the layers faster. And that makes a real difference to how effective the NOC team at the operator can be. And then, of course, I have to play ChatGPT bingo. So I got it in there. That's number one. Once you've got those insights, then you can feed that sort of data through AI, as Vikram was saying, not just to derive insights, but also to help the operators understand what, not just to predict, for example, that there's going to be a capacity crunch here, but also, hey, something's going wrong over in this portion of the network. I can see that from the insights, and then have a conversation about how that might, what might be causing that and what you can do about it. So a lot of research going on with operators into that sort of capability going forward.
Osvaldo, did you want to add anything here? Should we move on to, yeah?
I can agree with, I think it's as Paul described it, there is different layers of APIs, and I think there is, I guess, an aggregation of those APIs depending on the business need. And I think by having this common data layer that we talked before, that has a huge amount of aggregation of network events and data that can be exposed through those APIs. So some of the realization of the use cases that Vikram mentioned in terms of how to use information to be able to be more agile, to innovate and to create new services is something that is one of those things which also we see from engagements that there is a very active role and investment from service providers to be able to work in a much more open ecosystem where they can expose APIs and to be consumed by not only operational activities, but also from B2B type of implementations.
Okay, so next I kind of want to talk about performance and latency, how they're so important and how we ensure them. So Paul, how does Microsoft help its carrier customers ensure high performance and low latency?
So there's, again, multiple aspects to that question, Catherine. We've kind of touched already on sort of speed of innovation and velocity of service offering, so I won't touch on that again. So let's look at it as some raw bit handling and proximity to the customer. So one of the challenges in the telco space is it does need relatively specialized hardware compared with generic compute. It can be specialized potentially in multiple different directions. So some of what you need to run very high throughput packet processing in the core can be different hardware from what you might be emphasizing when you're trying to run the RAN. So what we've been doing in Microsoft is first recognizing that although we're a cloud provider, that actually, despite having a very large number of different regions around the globe, that's still a very small number compared with the number of sites that Vikram and the rest of AT&T are managing, even if you only consider the core sites that they're managing, let alone each individual cell tower, which runs to hundreds of thousands in a typical country. So we've been trying to provide an easy way to put together and manage and maintain those edge clouds that you need. So we're providing a managed service to make it easier to get high performance silicon that you need but as a managed service that you can consume to make that easier to use. Because as I'm sure many people in the audience have discovered, that some of the NFV approaches to doing this were probably a little bit too homebrew and quite hard work to maintain. So a managed service there can be very good. So if you've got a nice solution to that in terms of the performance that's needed, and you can deploy it in the right places, then the telco can choose where to put the capacity that's needed to give the latency that's demanded for the particular applications, be that low latency applications, as Vikram and Osvaldo mentioned, or if it's higher latency tolerant, it could be a large capacity solution in a smaller number of data centers. So that sort of flexibility is what we offer through the Nexus program. But we also have other solutions, obviously. Some problems like the analytics space that I mentioned, processing literally terabytes, hundreds of terabytes, some operators processing a petabyte a day of data coming out to their network. That's got cloud written all over it. So where you do need vast compute to process a problem fast enough, then cloud can help there. But that's in a different dimension of performance from the sort of end customer bandwidth and latency aspect that is more obvious to some people. Anyway, lots of capabilities there.
Yeah, great. Osvaldo, what about Enea? What role does the company play ensuring these performance and latency requirements?
Right. So we talked before about this network data layer and this separation between the network functions, and Vikram mentioned those network functions in a cloud-native design are stateless and dataless. And that the main reason for that is because it's very, from operational point of view, it's much more fast and effective to be able to spin up and down network functions that doesn't hold that data. And this network data layer is the layer responsible in the network for providing that data persistency. So that's the layer where I think all data gets stored. And as we talked before, it provides different data models and flexible views in order to be able to consume that different applications, that information, and also to be able to extend it. So in Enea, we work with a number of telecom service providers, helping them to ensure network performance for securing that layer of data persistence, which is extremely critical. It provides that high performance and latency that you mentioned. So our products, Stratum Network Data Layer, is extremely robust and scalable telco-grade cloud-native solution that encompasses both UDR and UDSF, and that is according to the 5G 3GPP specification, but also includes a comprehensive LDAP directory service, because there is a much wider scale of consolidation of other applications beyond the traditional subscriber data management. So in Enea, we have the experience about consolidating and centralizing in this data layer over 100 applications from different vendors in different tier 1 operators in the world. And the reason why we build this product is to put operators or service providers in control of that data model, because that allows the flexibility to be able to work, we said before, in an open multi-vendor environment. And for that, I think we have implemented flexible schema management, which is an advanced data modeling tool that is a game changer in the way that in the ability to be able to work with different applications and solutions. And back to your questions about the latency and what Vikram mentioned before, there is two aspects to consider about this. First is that in a large scale and wide geographically distributed network, getting data close as possible to the consumer applications at the edge is critical. And that is basically to avoid unduly delays by the backhauling of all requests to a central point. But the second aspect to think about is that in a 5G standalone, any connection request coming from a device can easily convert it into 10 times more communication between the applications and the repositories of the data storage. So that if you combine the effect of this 10 times more transaction with the backhauling towards a central point, there is a higher latency effect to consider. And therefore, this is an important That's why we said before, this is very important to have a fresh copy as close as possible to the edge for those applications that they need to consume that information. And that's what we have designed in our solution. So having in mind those type of network needs as Vikram and Paul mentioned before.
Yeah, and Vikram, to get the operator side of the equation here, beyond selecting the right industry partners, what are some things that AT&T does to differentiate itself in the market when it comes to performance and latency? Because I know the company's been performing pretty well when it comes to these kind of reports and speed tests and all that.
Yep, sure. So we are always looking at opportunities, Catherine, to improve our customer user experience. We are very proud of our 5G network. It's very scalable, robust, and secure network. And our results speak for itself. If you see the first half root metrics, State of the Union mobile report. So we have been leading in terms of overall, in terms of reliability, accessibility, speed, data, call and text. We meet our customers, wherever it needs to be, including connecting to Microsoft Edge cloud locations with a distributed 5G core network, developing on-premise solutions for our customers with MEC, and moving the customer context closer to the edge. We work actively with all our vendor partners to reduce latency. So we worked on a couple of 3GPP CRs where we did how do we optimize, geo-optimize based on the user location? How do we select the closest SMF and the UPF? So we have implemented this CRs, we took it through 3GPP, it's implemented right now. We also are constantly looking for new innovation, new ideas. We work with the vendors, and if something comes up, right, we always drive through 3GPP standards, through CRs, to improve the customer experience and also the network performance. So that's from an operator perspective.
Excellent. And just a reminder to our audience to please submit questions if you would like for our panelists. Okay, so Paul, Microsoft announced Azure for Operator Nexus program at MWC this past February. So tell us a little bit about maybe the timing of that announcement, why then, and then any updates you can provide since then.
Sure, thank you for asking. And just as an observation, it was great to see so many people at MWC again this last year. And then maybe there'll be some more good stories coming out of Las Vegas session coming up soon. But yeah, Nexus was announced at MWC actually last month when generally available. So AT&T is obviously a lead customer for Nexus, as I think many people know, and was discussed on the stage in Barcelona. But it's now available to carriers globally. It is that managed edge cloud that that I mentioned a few minutes ago. So it provides a high-performance telecom-oriented set of silicon, including Fabric and an Azure ARM portal and APIs for managing it, but also combined with all, then fits very well with all the other capabilities that you can get out of the cloud, such as the automation orchestration, which is what my team developed. For both the workspace as well as the infrastructure. Sorry, I meant the workloads, but also the sort of analytics and analysis capabilities that require that sort of cloud scale compute that we mentioned. So a very important platform for us and a lot of activity with carriers around the world. Because they see the benefits that that managed solution to an edge platform can deliver for them, and can be savings on TCO of sort of 40% or so. That sort of capability obviously translates to the bottom line, but also just makes it easier to concentrate on your manpower and cycles on differentiating the network as opposed to merely building racks of equipment. And actually, to be honest, building racks of equipment isn't the really difficult bit. It's maintaining it for the next 5 years after that and doing all the software updates. That's the bit where the managed service can really come in and help. So a lot of good activity there. And we've got lots of different network function vendors that are onboarding to Nexus and to our ops orchestration capabilities there. We'd be very happy to work with more partners there if there's anyone listening on the call who is interested in how to derive the benefits that we can bring through the Nexus program to either their network functions or their networks. But yeah, overall, Nexus is a very key program for us in Azure for Operators. It's been going very well over the last few months, and we look forward to continuing to refine it into different niches as needed for customer needs going forwards, because silicon never stays still for very long. Yeah.
Excellent. And I know you said AT&T is a big partner there, but I also know that Enea has experience in deploying cloud native functions on Azure in this Nexus program as well. So Osvaldo, first, maybe you could tell us a little bit about Enea's experience with the program.
Excellent. Thank you. Yes, we have been one of the first applications in the control plane that started the pre-certification work in close cooperation with Paul and the Microsoft team. The Enea portfolio is completely software-centric and cloud agnostic. So we design our cloud-native network functions with a focus to secure portability on Kubernetes environment. So from that angle, the initial integration into the Microsoft Nexus platform environment has been quite straightforward. And our general experience is that our deployments in Kubernetes is much reduced compared to installing virtual machines. Most of the ongoing alignment with Microsoft is around what Paul mentioned, is around the getting into the Azure Operator Nexus pipelines for automation for lifecycle provisioning and deployment. And our goal is to publish through the Microsoft catalog the Enea network function resources for having a CI/CD and continuous operation experience, as Paul described it. So from practical or more technical perspective, I think our experience with Azure is that it implements quite important functionalities for telco-grade. Things like SR IOB, allowing multiple physical interconnect cards to improve resilience and performance is very important. We also use functionalities typical like Multus for VLAN in order to protect the traffic separation between management, egress, egress, and network data. So we have been from an early stage that we have started this journey with Microsoft, and at the beginning things were in flux, but overall I think we have a very good, deep, and good collaboration between both companies. So we are pretty happy.
Great. All right, Vikram, what can you tell us about AT&T's experience with the program?
Sure. So Microsoft acquired our network cloud software and IP along with our development and engineering team a couple of years back. So Microsoft today is like a technology provider for network cloud. So we continue to deploy our 5G network functions in network cloud. It's a multi-vendor cloud. And at the same time, we are working with Microsoft on the Azure for Operator or the Azure Nexus Cloud. That's the next generation, that we plan to migrate our telco workloads to. So it's been a journey for us with Microsoft. For Microsoft, they're building a telco cloud with the network cloud experience. And what Microsoft brings to the table is a lot of automation, tooling capabilities, and the experience with cloud. And we bring the telco part to it. So for us, working with Microsoft, has been a very good experience. Especially, we have been working with the vendors so that they pre-certify the applications with the Microsoft Cloud, and we get this integrated solution back, and we can deploy it in a multi-vendor environment. And I think Paul and Osvaldo touched upon this. The key thing for us is automation and ADO pipelines. The lifecycle management, once we certify something, getting it deployed in the network, rolling it out fast enough across hundreds of locations, that's a challenge. So with the ADO pipeline, we have developed like one-touch automation. So, we can deploy our applications faster in the Azure cloud. And also, we are bringing in new innovations. And, for example, we are increasing typical Kubernetes lifecycle is like 12 months plus 2 months for CVs and patching. But we are pushing with Microsoft through the CNCF forum to increase the Kubernetes lifecycle, to 2 years, so that we have long-term support for Kubernetes. So this helps us, operators at our scale to deploy our applications so that by the time we deploy, the Kubernetes version is not end of life, right, or end of maintenance. And the other thing is the tooling capabilities with Microsoft, the AI ops, they are really helpful for us, and we have seen a lot of benefits with the Nexus Cloud. So I think overall it's been really positive for us, with our partnership with Microsoft.
Great, and we have an audience question here that is directed at Vikram, but I would, if possible, like to kind of get everyone's perspective on it. But first, Vikram, what is AT&T's view on Open RAN, and are there any plans to move towards that?
Yeah, sure. So yeah, we are actively looking at Open RAN. So our strategy has been to first, fully virtualize cloud native, the core side, take the experiences that we have learned from there and apply it to the RAN. Because a RAN is, we have thousands and thousands of, cell site. So we need to have a good solution in place. So our next focus is definitely on the Open RAN part.
Great. And the perspective I was just hoping to get from Osvaldo and Paul, if you feel like sharing, is just kind of pretty broad. How does Open RAN factoring in if we're talking about scaling these networks? Maybe some of the challenges associated with that. Some of the things that are exciting. Osvaldo, if you wanted to start.
Sure. We are quite active on Open RAN from the angle of traffic management. I think today, Enea, through a number of acquisitions, one was OpenWave, has introducing the company capability for traffic management for standalone platforms for that. And in that, we do a deep analysis on the machine learning analysis in terms of what is the traffic like to help us to optimize, like for instance, to provide a good video experience across all users. And that intelligence, I think, is something where we are prototyping and working on in terms of how to bring that. This is typically this type of network functions have been deployed in the GI interface, which is basically the IP layer on after the gateway. But we also realize that some of that intelligence is very needed in order to be able to steer traffic in a more intelligent way than today is done in radio. So we are looking at how to bring some of those capabilities as non-real-time applications on top of the RIC infrastructure of Open RAN in order to help also from doing a more proactive steering of traffic in real time based on what we see. And we have built even commercial implementations that we have in terms of analyzing pattern behavior. So we can predict when and where congestion will happen before it hits the network. And by that, we trigger optimization of service or traffic in order to avoid that type of degradation of service across the network.
Great.
So actually, if I may add, Catherine, I think a really interesting question that brings together the themes of most of the questions you already asked, which is obviously there's nothing pretty much more extreme in terms of performance and latency than running the RAN at the edge. So in terms of the sheer silicon needs that are needed, and obviously right out at the edge, the very fact that it's at the edge makes it an order of magnitude, probably even 2 orders of magnitude more physical sites that need to be managed than for anything in the core. So there's a phenomenal volume of scale involved there in terms of all the challenges about automation. If the carrier chooses to go down that direction, then dual vendor or even multi-vendor in the ORN, that makes life really quite interesting because of the sheer scale of things that could go bad very quickly if that wasn't well automated and well structured in terms of the deployment. So I think it's a really interesting area that actually relies on lots of the same tools and experience that's needed for what we were just discussing about the core, but it's going to be tens of thousands or even 100,000, that sort of scale of small sites rather than, you know, tens or hundreds of multi-rack sites. So different phenomenon, and probably also slightly different push in terms of direction, in terms of where it goes in silicon, so slightly different edge cloud hardware requirements. But we think it's a great direction for the industry. And again, being able to help our customers get to the point where they can manage that scale of complexity in a virtualized cloud native manner rather than what was typically historically more sort of physical appliance based, I think is a challenge we hope to be working to solve with both partners here today, but also the industry as a whole over the next year or so as that starts to build a head of steam behind ORN. Yeah.
Okay, so we danced around artificial intelligence. Paul kind of teased ChatGPT a little bit, but Vikram, I just wanted to ask a direct question about how AT&T is using AI in its network operations and maybe how it's hoping to use them, whatever you feel you can comfortably share with us.
Sure, Catherine. Yeah, so we have our version of the ChatGPT called Ask AT&T. So, you know, we use it for everyday, it's been trained with 3GPP standards, and, you know, we have trained it, for our day-to-day work, to either, we need to write some summary, a one-pager, white paper, if we get like a writer's block, we use the Ask AT&T. It's a version of ChatGPT. Also, apart from day-to-day stuff, right, we also use AI, to do like, some network insights and analysis. How do you predict which part of the network is going to get impacted, right? So we take data, ingest data from multiple 5G sources, and we feed it to our analytics engine. So this helps us to do some predictive analysis using like 3GPP cost codes. So we can say, hey, you know what? In this area, we are seeing a lot of failures coming with this particular cost code. Let's start looking into it, right, before it leads to a full-blown outage. So that's those are the areas that we are looking, from an AI perspective.
Excellent. Something else that I know is kind of a hot topic around 5G, but hyperscaling these networks and these services is workforce. So Osvaldo, I just wanted to ask you kind of your perspective on what workforce challenges maybe exist, whether that's for your carrier customers or even people in your space. If you could just kind of comment on some workforce challenges around that.
Yeah, definitely the all AI tools is something where I think we are looking at and we are implementing. I think I'm a strong believer on this co-pilot type of approach. Mm-hmm. Or the nature of our network functions is to collect data and to aggregate data. I think there is a very big opportunity to also to help on how to provide or to give an insight about what could be a good operational action to take place when you aggregate all this volume of data. So I think that definitely as I think Paul mentioned as well, the complexity is getting higher as the number of network functions in the network are growing. Also these data tiers or decouplings between layers also create dependency across those. So it's harder to take isolated decisions. And that's why I think to have an aggregated view in terms of what is the insights that you can derive from the data that you have more across all these layers, I think it's something that I I guess the industry will work much more on this. I think we are from the network data layer doing our steps to bring those type of capabilities, as well as we do it from the security angle, where we are building AI machine learning algorithms to detect what kind of signaling threats we see in those interfaces as well, in order to help on the workforce to what action should be taken.
Mm-hmm. Absolutely. Okay, so I have another question here for you, Vikram. What is AT&T's view on utilization of UDSF or unstructured databases to make cloud native networks stateless? Timing and first applications with USDF integration, ?
Sure. So we do use UDSF for certain network functions. It's not used across the board. The reason being is we do a lot of operations in memory. So we have like, for example, if I take an AMF, right? So AMF is handling all the mobility functions, right? So for us to go and do a lookup into the UDSF, pull the context out, it will work, but we see it more efficient doing it in memory using like an in-memory database. But for certain network functions, it makes sense to have like a UDSF database. But for others, it makes more sense to process it in memory in terms of faster processing. So I would say it's a case-by-case basis. It's not like across the board. So that's our view right now.
Okay, great. And Paul, I'm going to direct this audience question to you. How are service providers and hyperscalers collaborating on providing inter-hyperscaler support or shifting the application load from one hyperscaler to another, for example, based on where resources are available from hyperscalers, or if one is under stress or has an issue?
Sure. Well, I can provide lots of blue paint if that helps. But no, seriously, it's a very important topic for people, in particular around, there are understandable concerns that move from what was a network equipment provider potential lock-in to a cloud lock-in. But some of the topics we touched on earlier around open APIs, open data models, that's what makes it much easier to move where needed, either from private cloud to public cloud or even between public clouds. Now, which public cloud's the right fit for an individual telco or indeed any other industry does depend on either simple things like who's got regions in the right place, or much less obvious or more detailed things around the nuances of in particular services like particular database, particular AI capabilities. So we very much have the philosophy in Microsoft to meet the customer where they are, meet what their needs are, and provide them what's needed to do that. We work with both our own services team, our CSA teams, but also with the major global SIs for any sort of such project where migration is needed. And I'm sure each of our competitors do the same thing. So it's open APIs help with that sort of portability if needed. But then as the consumer of the cloud service, wherever you're getting it from, make sure it matches your particular needs in terms of performance, the exact feature functions, and just ultimately it still comes down to the relationship you have with your suppliers and how that's going to work and how well they understand your business.
Yeah. Great. Vikram, if you can you share with us which network functions are deployed on Azure and if it's deployed on premise or in public cloud or in Azure region, and kind of has there been a change in the AT&T strategy around this over time?
No, our strategy has remained the same. So we, in 2019, we made a decision to be like a public cloud first company. So we have migrated all our IT workloads to the Azure public cloud. And right now, our 5G network functions, it's running in our network cloud that's owned right now by Microsoft. Right now, we are at moving our workloads, the 5G workloads, to the Azure Nexus cloud. And we did some proof of concept testing of having certain network functions on the Azure public cloud. But we feel, migrating it to the Nexus or the AFO, Azure for Operator Clouds, that's the best place, for the 5G network functions. So that's where we are right now.
Okay, we're almost at time, but I got another quick one here for you, Vikram, that you could probably squeeze in. Regarding AI tools you use, for example, for predictive maintenance, is this developed by AT&T or is this integrated by a vendor or integrator?
Yeah, so right now it's in-house developed tools that we are using, but we are also going to work with Microsoft to see how we can leverage their tooling, and possible synergies are there. So right now it's in-house developed tools. Yeah.
Okay, excellent, perfect timing. Okay, thank you to all of our viewers, and thank you, of course, to our panelists. I hope everyone enjoyed the discussion. Have a great rest of your day.
Okay,
Thank you very
thank you.
much.